have, when's the Unit 1 test then?
Okay, let me put up the test dates. I wasn't sure if we're doing pretty good as far as covering material.
Yeah.
Test 1 will be, I have it on the calendar as 5/27 through 6/1. So it'll be the week after, or during the week of Memorial Day. So Wednesday through June 1st, Monday, the following week of that one. So I usually give about 3 class days for the test, and you can work on that. You can use your notes, homeworks, anything like that, but just no people. Okay.
And how does that work? Is it just at home online?
Oh, yeah, it's just at home. It's just like a homework where I give you the problems on a PDF, and you can fill them out, and then you can do it by notebook paper or print out the test and fill it out and then email it, or not email it, but post it to Canvas. It'll be like a homework where you post to Canvas, file upload, and we'll check your understanding.
Perfect, thanks.
I'm trying to make it a little bit more short answer than computational, because you can use a calculator or anything just to calculate the answer. So we need some more explanation about how these things are working, the structures, and explaining the mental math or whatever, explaining how to do different bases. So we'll have some short answer on it as well. So great questions. Any other ones about the course?
I have a question. So I've been doing the fluency journal and numbering your paper 1 through 25, but are we supposed to do that like every day, once a week, like the questions for the addition and the multiplication?
That one you're supposed to do just once.
Oh, okay.
At the beginning of the course, you'll go through that just once, and then throughout the course, you'll just do like a 30-second challenge and write down your thoughts on that one for class day. Or you can do some of the activities. Have I sent you any other activities besides 30-second challenge yet? Okay, because we'll introduce those when the course comes. Maybe I'll go ahead and send you the email so that you guys can have other ideas. But there's some 30-second challenges from the app I was saying just to start out with. So now that we've done that this is week number 3. Now that we've done that for a while, I can email you some more activities.
Do we choose what we want to do, or
Yeah.
do you want us to do certain things on certain weeks?
No, just have you choose what you want to do. The fluency test questions will be stuff that, like, for example, what we're going to do today is we're going to do some mental math today. That will be under the category of fluency, so that you can do other thinking strategies besides the algorithm or the step-by-step process that's traditional that we teach, to do some math. So we'll do some of that today. Ways to think. Great questions. Any other ones?
I had a question about the homework. Is now okay to ask that?
Homework on the 1.7 or 1.6?
Yeah, so it's
1.6 and before, then yeah, you can ask it, but not 1.7, because we haven't covered that today yet.
I believe it's 1.6. What have been the homework that's due today?
Okay, yeah, that's 1.6, sure.
Okay, so I'm just curious on question 39. It had us go to a number bond discussion thread on Canvas.
Okay, there isn't one, so skip that one.
Okay, I'm I couldn't find that. Okay, so we just don't have to worry about that.
Yeah,
number
just
then.
that one.
Okay, that's fine. That's the only question I had.
Great.
Tracy, do you check your Canvas email often?
Yeah.
Oh, because he emailed us last week after class and said not to do number 39.
Oh, sorry, I must have missed that.
No worries, I just thought I'd make that clear.
I get tons of emails every day, and I hope that I don't miss one of your guys'. So if I do, and then you can email me again. But I don't think I'm trying not to. But sometimes it takes a little bit to get back to emails. But that's totally understandable. Okay, any other questions about homeworks or anything? Because I like to give time for that. You like to give time for fluency practice. Okay, let's go ahead and get into our lesson then. We're going to learn more about addition since we're in that chapter. Unit 1 is on addition. So we're starting to develop ideas for the algorithm. Sometimes students will have strategies of their own to add two numbers together before they even come up with anything formal like the algorithm, which is the step-by-step process that you all know. You can go ahead and share my screen with my iPad. Okay. And so we begin with a reading on addition strategies. Okay, I'm going to stop for just a second. And I'm going to pull up a PowerPoint, a couple of slides from PowerPoint about addition facts. Okay, we use addition strategies to learn the addition facts. You guys all know and love the addition facts. Maybe you've studied the multiplication facts more, but there are addition facts that you learn. Oh, there it is. I'm going to skip down to this one. So on this slide here, we have all the addition facts from 0 to 10, and there's 121 of them. And the course standards say that people in kindergarten add and subtract between 0 and 20. Or first grade, I can't remember which one it is. First grade, I think, is within 100. So yeah, kindergartens add and subtract within 0 and 20. And we have the first up to 10 plus 10 addition facts. So how are you going to develop that type of thinking with your students? Well, we do it with strategies. We take groups of facts at a time. So one thing that you can do is you can think about counting, connecting counting to addition by knowing the facts with one and two more than a number. So if you want to do like 1 plus 3, all you have to do is take 3 and then add 1 to it. Or here's 3 plus 1. So with the commutative property, we can do either one and just count on from that number. Okay? And so you start with 3 fingers and you put 1 more on and you count and you see that the sum of 3 and 1 is 4. Same thing with 2. 1 and 2 are easy to count on from. So you start with 3, add 2 more fingers, you get 5. Okay? So using fingers is a very good manipulative and tool. So a lot of popular past beliefs is that it's bad to use fingers, but actually fingers are very helpful. They're just the concrete model, something that you can touch, that you can do addition with, or other operations. So these facts can be memorized in these columns and rows by just counting on. So adding 1 or 2 to each number is counting on, and you can start by doing that. The additive identity we've talked about. Adding 0 to some number gets you just that number. Then there's doubles. Now doubles are important, and they're kind of easy to remember because you do 4 and 4 is 8, 6 and 6 is 12. You can do kind of chants and recitations. We have doubles a lot where we have eggs. Spiders have 4 sets of legs on each side, 2 4 legs on each side, crayons and calendars and fingers, 10 and 10 fingers, 10 fingers, 10 toes, 5 fingers on each hand. So 5 and 5 makes 10. So lots of ways to tie it to real life. And to, that's what this slide is right here, this picture. And you can see these different pictures. Tying math to real life is very important. And so you can tie these doubles facts. Tens combinations. Okay, this is the kind of the opposite angle as doubles, the opposite diagonal. And tens combinations can be used to start working on, because it's good to think about what makes the next 10 for mental math strategies. What number can I add to 2 to get to 10, for example? You add 8. Okay. We'll go over these in a little bit more detail. And then the associative property, making tens, we'll talk about this too. I think this is more commutative stuff. Let's see what that one is. Oh, there's a commutative. So you only need to memorize like a certain number of facts, because the other half of the facts are the same. Using the commutative property, you just switch the numbers. Near doubles are great. We'll talk about how to do those. You take your double, like 2 plus 3, I can figure out by adding 2 plus 2 and then 1 more. 2 plus 2 is 4, plus 1 more is 5. So near doubles, you can memorize those. So that's a sequence of slides that you can look at, because I'm recording this video. And you can like pull that up and go back through them if you want. Or you can take notes if you take notes. Okay. So I'm going to unshare my screen. Remember where that is.
It should be at the top where
Yeah,
it says
good.
your screen sharing.
But it's not there. Oh, there it is. I hit it. Now it's behaving. Okay. All right, so we're going to go back to addition strategies. Talk more about what I've shown you in detail. So for adding, for number 1, we add 1 and 2. So any fact that adds plus 1 and plus 2, we just want to count on. Okay, so counting on means that I start the number and start counting forward in the numeric sequence, 1 or 2 more places. So for example, we have 4 plus 2 is 6. You want to start at 4 and count then 5, 6. Adding addition strategy number 2, we're going to add 0. Adding 0 is trivial. Once pointed out. Okay, or taught. For example, 4 plus 0 is 4. Okay. I operated on my number, but a quantity, but then it didn't change. Number 3, commutativity. Commutativity. That's a hard word to say. Or using the commutative property. They use that when they discover it. You'll have exercises that you'll have your students do while they'll see that that's the sum when they put together like a bunch of blocks, like they have 4 blocks in one hand and 5 in the other, and they put them together, then they switch it, like another problem, they'll have 5 blocks in one hand and 4 in the other. They'll notice that they both equal 9. So no matter how you add them, they'll both equal 9. And they'll say, oh, does this happen all the time? This is a great exercise. If they ask that question, you say, try some more ideas out and see. You can have them explore it. Then we talked about the doubles facts. Okay. 2 plus 2 is 4, or you can say 2 and 2 is 4. 3 plus 3 equals 6. 4 plus 4 equals 8. And so you can kind of do the doubles with some sort of chant. You can do like 2, 4, 6, 8 chant. Okay, 2 plus 2 is 4, 4 plus 4 is 8, and things like that. Number 5 is tens combinations. Okay, these are some like phrases. All these strategies are phrases that you might have heard of. You might have heard of some, but not all. But these are kind of things that are used in the field. So if you talk about tens combinations, the other elementary teachers will know what you're talking about. So if they mention that, then you need to know what they're talking about. Tens combinations are learned through practice. Okay. And one activity, well, let's go ahead and see what they are here. So they're 1 plus 9, whatever equals 10. 2 plus 8 equals 10, and so on. One activity you can use are tens frames. They usually look like just a box. With 10 squares in them. And sometimes you can use a manipulative like a chip. You can have them draw a dot on a picture. Okay. They'll give a tens frame with 3 of them, 3 of the boxes filled in. You have to think about, okay, so how many to complete the tens frame? Okay, so they have to think about how many that you need to fill up. That's the tens combination. Or you can think of it as a tens complement, whatever is left to fill in the tens frame. Another strategy is adding tens. Okay, they can discover this, such you can point it out to them. So an example is 7 plus 10 equals 17. So you take the number, whatever you're going to add the 10, and you increase the 10's value. Or if it's like a single digit, you can increase the value and put a 10 on there. They have a thing that's called a hundreds chart. So they can discover how adding to 10. So if you're getting into like the second grade, no, the first grade, then you can add 10s because they add and subtract within 100. You can get a hundreds chart out. And it's actually just kind of a grid that has the first 100 numbers on it. Some of them start with 0, some start with 1. So you can kind of Google that and to see what they are. But I'll kind of lay out the first part of it. Here. So you have all the numbers in a row up to 9 or 10, depending on where you start. Okay, and right, it's also like kind of in a chart too, where they have these types of things. spit it out. And it continues on forever. So when you add a 10, or sorry, when you're adding ones on this chart, you're counting this way. Okay, you count to the right. When you're adding 10, you take your number here and go down. Okay, so if you're adding something like 13, or sorry, 11, you can count to the right one and down one. Okay, so that's a hundreds chart, and they're pretty useful for just a drawing or a way to lay out beginning addition problems. Okay. Soon after they see these drawings and these concrete materials, they'll want to do something more efficiently, and they'll go to numbers and algorithms. So these are starting to go to algorithms because I'm starting to use mental math on the numbers themselves. Okay, so it's kind of in a transition here. Number 7 was the relating to doubles. Okay. They're practiced as mental math. Relating to doubles are things that we mentioned before. If you have 7 plus 8, okay, you can break up the 8 into 7 plus 1. And then you can say, I can add my 7s together and then add my 1 on. Okay. Going from this step to this step is using the associative property. Okay. We talked about that a little bit, where if you have 3 numbers to add together, it doesn't matter which way they add together. You can add the second 2 or the first 2. Sorry, the second and third, or the first and second. This double, we know, we practiced it as a class, 7 and 7 is 14, but then you have that adding the 1 more on. And that's how you can learn this fact, is 7 plus 8. Here's another example. You want to add 7 plus 9 together. You can say 7 plus, break up the 9 into 2 plus 7. I'm sorry, let me write that the other way. Break it up into 7 plus 2. That 9 can break up. And now you have a double, 7 and 7 plus 2. Okay, that's equal to 16. Because it's coming from the 7 plus 7, 14 idea. So relating to doubles, they have one that's called, another example. Let me do 7 plus 9. Is it 7 plus 9? Yeah. So if you want to do 7 plus 9 or doubles plus 2, okay, yeah, let me put these down. Sometimes they'll have things called, these are called doubles plus 1. These ones are called doubles plus 2. Okay, that's the name of these facts. Okay, I got a 10-minute warning for Zoom. Well, and I know that somebody had emailed me alternate program. I still need to look at that. We'll try to get this down a little bit better. But yeah, about 9.5 more minutes, we'll reconnect. So going to these doubles. Okay, then there's like this strategy called twice average. Okay. So if I have doubles plus 2s, you can do twice average, like the 7 plus 9. The twice average way is like 7 plus 9. And you take the average, is going to be 8. Okay. And then you're going to do twice 8. Gives you 16. And that's the answer. Okay. So if you're adding 2 numbers that are on opposite sides of a single number, like 8 is in between 7 and 9, then you can do twice 8 and get to the answer. This leads us into compensation, the last one. Is a helpful strategy. Sometimes the numbers that end in 9 or 8, they're kind of harder to add because they're really high for the digits, for the place. And so sometimes it's easier to just add a couple on there and you can get to the like 10 or something. So that's compensation. But if you start adding a couple of things to one digit, one of the numbers in the math addition problem, you have to compensate for it with the second number. So we'll start with a simple example, 9 plus 4. Now 9 plus 4 is really close to 10. So how about if I take 1 from the 4 and put it with the 10, with the 9 to make it 10? Okay. So I'm going to take 9 and 4. I'm going to take 1 from the 4. So that means I'm going to have 9 plus, breaking up my 4 into 1 plus 3. So I can use the associative property again to take it to with the 9. Okay. And then you add that together to get 10 plus 3, which is 13. Okay. So compensation takes 1 from one number, puts it to the other number. And you can make the math easier that way by looking at the numbers in their entirety. Now, here's another way of doing it. Take 9 plus 4, and I really want to just add 1 to it, so I will. 9 plus 1. Now, what happens to the 4? I need to compensate for the 4. And in an addition problem, if I take 1 and I just add it to my 9, I need to compensate for it by subtracting 1 off. Okay. This is a similar idea to what we just did. Okay. So I took 1 from the 4 and put it with the 9. And we have 10 plus 3 again. Equals 13. Okay. Let's try another one of those. A little bit bigger. We're going to do 28 plus 13. Okay, we're going to use compensation, which is also practiced as mental math. (28) and 13. Now 28 is really close to 30. So I'm going to add 2. I want to get to 2 from the 13. Okay, so I broke my 13 up into 2 plus 11. And then I can do 28 plus 2 plus 11 using associative property. That's equal to 30 plus 11, which is equal to 41. We kind of put a box around these numbers. These are my answers. Okay, or we can do it the other way, slightly different. 28 plus 13 is equal to 28 plus 2, which I want to just add together. Compensation, I take 2 off of my 13 to maintain the addition, the putting together. I need to have the same answer. And so I have 30 plus 11 is equal to 41. One more example with this one, with 3 digits, 138 plus 370. You can do compensation with tens places as well, not just the ones place. So what I really want to do is I want to add 30 to the 70 right here, so I can make it even 400. I can pull from my 38, 138 as well. So I'm going to say, okay, I'm going to break my 138 up into 108 plus 30. Okay, notice that I'm working with the other side, the other number to compensate. So you can work with both numbers in your addition problem, the first one and the second one, for compensation. 108. plus, sorry, no, I don't need that here. We're using the associated property to add the 30 plus the 370 together. That's 108 plus 400, which gives me 508. The other way you can do that is going to say, okay, I'm going to do 138 minus 30, because I want the 370 plus 30 to happen. So I think about this first, and then I compensate with that one. And when I'm done, I have 108 plus 400. That equals 508. So those are strategies for addition. The commutative property helps you. I'm going to do an example with the commutative property, like from the homework. It helps you add up a list of numbers. Sometimes you can look for numbers where you're adding up several numbers that match up to make a 10, like 10's complement, 10's combinations. So here's one that's kind of like one from the homework. Do 75 plus 12 plus 3 plus 25. So let's have you guys chime in and say, okay, if I'm going to add these numbers up, which one should I do? How should I do it to make it the easiest?
I would do the 75 and 25
Okay, why did those two stand out to you?
because they're both in fives.
Okay, yeah, so you can make the numbers a little bit easier because it doesn't matter which way you add the numbers. You can put the 25 here using the commutative property by switching it here and then switching it here. Okay. That will make 100.
And then, oh,
So that's my answer there. Now, on the homework, you'll have to do mental math, but I want you to show which one you're going to do, like which steps you're taking. And so something like this is helpful, where I showed show it as an equation stack, a bunch of equations there, showing one step at a time. Now, to 25, I'm putting all the way up to the front here, and that's a commutative property. Okay. Let me go ahead and go back to my iPad. So you want to kind of structure them as one step at a time so I can follow your thinking. And you want to label any properties that you use that will help, kind of like I labeled in this example. Use the commutative property to get from the first step to the second step. I have another example in purple. We're going to add these numbers together. So go ahead and take like 2 minutes to add these together. Looking for commutative property, looking for compensation. No, sorry, 10's combinations, 10's complements. You might have to rearrange some of the numbers. It's okay because it's addition. And do that in your notebook, and let's have somebody volunteer, explain how they did this.
Is it okay if we do more than one combination in the same step, or do you want those broken up into each step?
Yeah, showing more is better.
Okay.
Okay, Sid, did you have one?
Yeah, so I did the commutative property and I switched the numbers to 29 plus 11 plus 16
Okay.
plus 4 or 14 plus 3.
Okay.
And then I did 29 plus 11
Pause there. And why
Okay.
did you do that?
because now I have all the 10s together.
What do you mean by tens together?
So 1 plus 9 is a 10 and 6 plus 4 is a 10.
Good, yeah. So you're looking for the tens complements, tens combinations to make a nice 10. It's easy to add with tens, as you will see. Okay, now carry on with what your next steps were.
Okay, so then I did 29 plus 11 is 40.
Mm-hmm.
And then I did 11 plus 16 is 16 plus 14 is 30.
Okay.
And then I just brought the 3 down because I didn't do anything with that yet.
Okay.
And then I did 4 plus 4 is 8 minus 1 for the near doubles because 3 is not 4 is
Okay.
7.
Good.
And then I
So
just
those
did
are 7 tens, right? So you're doing 4 tens plus 4 tens, subtract 1 10. Okay.
Mm-hmm.
And then the 3 comes on to the right. Right. Now the property that's used here in the second step is a commutative property.
Yeah. So commutative and then tens combination and then near doubles.
Very good. All right, so I didn't track your near doubles, but whatever you did was fine there. Yeah. So that's a couple of examples of some homework problems that are relating for this mental math. Let's see, moving on. They also talk about, they do some, let's see, they do some other compensations. Okay, so let's go do another example. Like orange. So they'll have you dive into Math 3A, Prime Math 3A, where they're just adding some hundreds. Because in third grade, they do add and subtract within 1,000. So they're adding some hundreds here. Yeah, so they do something like 348 plus 103. So if you add those together with using the compensation method, I need to do 348 plus 2, because that'll get me to my, I want that to happen because that'll get me to 350. So breaking up the 103 into 2 plus 101, so I can eventually get 348 plus 2 plus 101. And that'll be 350 plus 101. That's equal to 451. So this part right here, where I'm adding from here to here, I did the associative property. Okay. Or you can do it like this, 348 plus 103. Now using compensation, okay, I'm going to add 2. I'm going to subtract 2. Oops. Like that. Okay. They also take a little brief, which I'm not sure why they put this in here, but you'll study more about this in 2015. A little brief example with with equality. So you're being careful with the equal sign. Okay. They take examples from here of that. So like, for example, they'll say, if I said that Dr. B is equal to $5, let's give him $50. Is that correct use of the equal sign? If I say that I am equal to $50?
No, because the two things aren't the same value.
Yeah. So we need to make sure that if we don't say things are equal, I am equal to $50. We have to say something like, Dr. B has $50. Okay. Let's say that I want to say, okay, I'm going to do some rounding. $29.78 is equal to 29.45. Is that true? Is that appropriate use of equal sign?
Yeah, because it rounds up. Like anything over 5 rounds up, so it would make that 7 and 8. Oh no, that's not right then.
Because it's not the same.
Yeah, they're not equal. The equal has to be exactly the same. So what should I put here instead of the equal sign?
It's the squiggly equal sign.
Good. Just help me remember that it's the squiggly,
That.
which means approximately equal to.
Wait, I've never seen the squiggly equal sign. What does it mean?
Approximately equal to.
Okay.
That's why we're kind of going over this, because they'll use this in the book, I think. Okay, it's a squiggly equal sign. Let me try and draw it better here. It's just wavy lines instead of straight lines. So you'll see that in homework. And then this is like, if I wanted to do 3 plus 15, I'm just going to copy this one from the book. Divide by 2 plus 6. If I want to do all that stuff, can I do this? Equals 18 divided by 2 plus 6 equals 9 plus 6 equals 15. Can I do that? Wait, hold on. That was the right answer. Okay, let me rewrite that one. I was copying the wrong part of my notes. Okay, forget I said that. In this one we have, okay, so the problem was 3 plus 15. And then we divide it by 2 plus 6. So when I do it, I do 3 plus 15 first because the order of operations says to do that. So you put 18. And then that's going to be equal to 18 divided by 2. That's going to be 9. And that's going to be equal to 9 plus 6. I'm going to say that's 15. How about all that stuff? Does that look good?
No.
No, equal sign means that you're saying every part of this equation is equal. So this needs to be equal to that, 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 needs to be equal to that. But they're not all equal.
Can you scroll up a little bit?
Sure.
Thank you.
Okay, so I have 3 plus 15 divided by 2 plus 6. 18 divided by 2, because this is my thoughts. 9 plus 6, 15. Okay? If you're going to write something down, be careful with your thoughts and that all of the parts of the equation are the same value. Okay? 18 is not equal to 9. If I take this value here and that value, those are not equal. But if you want to string them all together, they need to be equal. So if you don't string them together and you still want to show your thoughts, you want to use like arrows or something. Okay? 3 plus 15 is equal to 18. You can rewrite the equations. 18 divided by 2 is equal to 9. 9 plus 6 is equal to 15. Okay, so you can recopy things Okay. And that's probably the easiest way to do it. But we'll talk more about that in 2015. So it's just a little bit of the homework, but don't worry about it right now. The other big section for this part of Unit 1 is adding with not just mental math, but we're going to add with the concrete models and drawings. So what we want to do is we want to add, let's see. We're going to add 37 plus 82. No, bigger than that. 85 with a chip model. Okay. So you need to add those together. So adding with chip models, adding with base block models, and adding an expanded format. So we're transitioning to the algorithm where we're going to add with some more concrete and pictorial models, and then you add with some, starting to get with some abstract models. Okay, so the first concrete model was chip model. Okay, and you have chips, but I won't make you get them out because we're running out of time. We only have like 10 minutes. But the drawings will suffice because you know how to translate between drawings and chips, but your students won't. So do the chips with them. We have 37 and 85. So I'm going to add those together. The chip model places everything in base and each place value based off of the base. Okay. So when I get this chip model, I won't go into the thousands. So my first place is actually going to be in the hundreds place. Okay, this will get into the hundreds. So in my chip, so I use a chip chart that has the hundreds, the tens, and the ones. Okay. And if I'm going to add two numbers together, I'm going to add them piece by piece. So I'm going to model 37 with these by doing 3 tens, 3 chips in the 10 place, 7 in the ones place. Okay, and it doesn't matter the configuration of them. Now 85, I'm going to model 8 chips in the tens place, and I'm going to model it below so I can see what the separate numbers are, and 5 in the ones place. Okay, so it doesn't matter how you arrange them. But what does matter is how you group them together, because what you're going to do is you're going to group them together. Go to purple. According to the base value. Start with the ones. Okay. So I'm going to get every time I get 10 ones, I'm going to group them together and put a chip into the tens place. Okay. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Group these 10 together because once I have 10 ones, you can group them together and put them into the tens place. Now I don't have any more groups of 10 there. I just have these 2 leftovers that I'm going to just leave there and save them for later. So I'm going to circle them as leftovers. The next place over, I need, in the tens place, I also need to do the same thing because that's the structure of the base 10 system. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here are 10 of these from the tens place. 10 tens together make 100. I don't have any more 100 tens to group to 100. I have 2 of those left over. And so once I've done that grouping, I can go ahead and write my numbers down from, there's 100, 2 leftovers for tens, 2 tens, and 2 ones. Okay, so 37 plus 85 is equal to 122. Okay, now this is something that you can maybe kind of connect already to the algorithm where I'm grouping things together. And in the algorithm, we say we carry the one, but we're not going to use that word carry because we're not actually bringing it somewhere. Sort of, we are, but we want to make sure our English words match our actions mathematically, okay? So we need to rethink our vocabulary here for a little bit. But the starting of the chip model is grouping the tens together and placing another 10 into the tens or hundreds. So there's the example of the chip model. I'm going to go ahead and do add, let's see, yeah. I'm going to go ahead and add 37 plus 85 with base blocks. Now we call them base blocks, but you can call them base 10 blocks because we're going to work in base 10 now. Okay, so I call them base blocks, or at least the book does. Remember that the base blocks we have, I'm going to show you my key again. I think it's pretty handy. That's equal to 1,000. The flat is equal to 100, corresponding with 100. The stick or rod corresponds with 10. And then the dot corresponds with 1. So that's what I'll use for my model here. I need to model 37 and 85. So 37 is going to be 3 tens and 7 ones. And 85, I'm going to kind of draw below it. 8 tens and 5 ones. This will be similar to chip chart, but we're using the base 10 blocks. Oops. Okay, so I'm going to add these together. I'm going to combine them. So in order to show combining with a picture, you can imagine just putting them together and exchanging 10 rods for 1 flat and so on. We combine with, again, with like these loops that go around. With base 10 blocks, you can combine any place, but you have to think about things that might come into the place before it or after it. So I go ahead and combine with my ones first. So I'm going to count out 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here is 10 ones. And with base 10 blocks, you have your students concretely grab the 10 little cubes together, put them into the bin, and exchange it for 1 rod. Okay? So you can show that by grouping them together with this loop and then drawing an arrow and doing a rod. Remember that in the pictures, we don't want to use math operations or math numerals. That's for abstract work. We use arrows and crossing out, okay, for these ones. Now I'm going to go ahead and count all my 10s together. So I see how many I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them here. So I circle that. And then I'm going to make that into a flat. Take my rods, put them into the bin, 10 rods, and exchange it for 1 flat. And as you can see that my flat, 2 rods, 2 little cubes are left, okay? And when we do that, we get to put 122 because that's how I'm assigning each of the, assigning each of the values. So I can now put my answer down based off of my picture of my manipulatives. They have this expanded format that kind of goes along with the manipulatives of the base blocks. We have 3 minutes to do expanded format. Add 37 plus 85. Actually, I'm going to change my problem. I'm going to put in some hundreds here for expanded format. We're going to add 537 plus 685 with expanded format. And so you can probably guess what this is. Expanding the numbers, we did that a little bit in the homework. where we add it, usually you depict it vertically, 537 plus 685. And I'm going to do adding 500 and 600 together, okay? Because I'm expanding my numbers by place. So go ahead and color code this. Start with yellow, no, we'll do purple. Okay, these ones right here are going to be first, 500 plus 600. Okay. You can also add on, break it down into the 30 plus 80, taking the tens place from each of them, and then you're also going to add on the ones place from each of them, which is 7 plus 5. Okay. So you can do this all separately. 1,100, 30 and 80 makes 110. 7 and 5 make 12. Okay. That's expanded format. And what I do is that once I've added those together, I add these are called partial sums. Once I find my partial sums with expanded format, I can add them all together. And so I have 1,222. Wonder how I got all that random numbers. Okay, lots of twos today. Okay, so that's expanded format. Okay, I believe that we have everything that we can cover today. Sorry to get too much interactive, but there's a lot more to this lesson. Do we have any questions before we close? We have like a minute. So there's lots of new vocabulary. So as you go through the homework and this lesson, study vocabulary. We'll be seeing these later on.
I don't have a question, but I have something to tell you. If you go to weaver.edu and then you just search for Zoom, the school will give you like the unlimited access to the 24-hour meeting session, so it won't time out.
Okay. All right, thank you.
You just fill out the request form.
Or look for something. Okay, so we're at time. I think that you guys have what you need for homework. Please let me know if you have any questions. Hopefully you'll enjoy doing the homework, or some sense of getting more complicated math. But we're working our way towards an algorithm of the way that we add with the compactness and the carrying and all of that jazz. Okay, so that's all I have. If you have any questions, you can send an email. You can set a Zoom meeting as well. Hopefully everyone has a good Monday.
Thank you so much. Have a great day.
Yep, you too.
Bye-bye.
Thank you.
Thank you.
You're welcome, everyone.